In order to find the integral from 3 to 5 of the function x cubed minus 2x squared minus 4 over x cubed minus 2x squared dx, we're going to realize that we have the same power here on the x variables. And so what we're going to start doing is we're going to divide this out using long division. That x cubed will go into that x cubed one time, and then we'll multiply the 1 by the x cubed minus 2x squared. And then what we'll do is we will change these signs and add, and that'll zero out. We made sure that we included this x term here by putting a 0 in front of it just to make sure that everything would line up. Well, it turns out it doesn't matter because all of this zeroes out and we're just left with the minus 4. So then what we found is that this function here, which we've rewritten here, is the same as, is equal to this function, 1 minus the remainder, 4, over x cubed minus 2x squared, the divisor. So what we're going to do then is we're going to set up a partial fraction decomposition here, just worrying about this 4 over x cubed minus 2x squared. We'll get the 1 later. And we'll do that by noticing that we have an x squared here, which is a repeated linear factor. So we're going to have constant numerators here. And then we have an x minus 2, another linear factor. So we have a constant numerator. Multiplying this out, we'd wind up then by just by clearing out fractions, multiplying both sides by this lowest common denominator, x squared times x minus 2. We wind up with 4 equals ax times x minus 2 plus b times x minus 2 plus cx squared. Multiplying all that out, we wind up with ax squared minus 2ax plus bx minus 2b plus cx squared is 4. And what we can do then is collect our like terms. We've got ax squared and cx squared. We'll factor the x squared off and we'll wind up with a plus c. Then we've got minus 2ax and bx. We'll factor the x off and we'll have minus 2a plus b. And then we have the minus 2b here. That's our only constant term. And all that is equal to 4. And the thing that we notice about this right side here is that there are no x squared or x terms. That means then that this coefficient, a plus c, must be 0. It also means that this coefficient, minus 2a plus b, must be 0. And then since the only place we're getting a constant is from this minus 2b, that means that minus 2b must be 4. Which then makes b equal to minus 2. Which then we can plug back in this equation right above, which will give us that a is minus 1, and then plugging that into the equation above that, we find that c is equal to 1. So we take these terms that we found, these coefficients, and we're going to put them in their respective numerators now. So we're now going to find this integral. Now instead of writing it the way we had before, where we had the original form of that function, we've written it after in the form that we get after we've done the division. So this 1 right here is this 1 here, and then we have a minus. And now this whole 4 over x cubed minus 2x squared we've written in the form that we achieved when we did the partial fraction decomposition. So they're equal. It's exactly the same. We have the same limits of integration. So now we're going to integrate. In order to do that, we might first distribute that negative and simplify this integral a little bit. So we're going to integrate this function here. And, of course, the integral of 1 dx is just x. 1 over x becomes natural log absolute value of x. 2 over x squared becomes minus 2 over x. Minus 1 over x minus 2 becomes minus natural log x minus 2 in absolute value. And then we're going to evaluate that from 3 to 5. So we plug in these values, 5 here first, minus, and then we plug in 3. The natural log of 1 is 0. So we're going to distribute this negative. Here we're going to have minus 3 minus natural log 3 and plus 2/3. Then we combine anything we can, like we take the 5 and the minus 3 and we make it a 2. I'll take the minus 2/5 and turn that into minus 6/15 because I've got 2/3 over here, and I'll have a common denominator of 15, so I'll make that 10/15. And the minus natural log 3 minus natural log 3, I can make minus 2 natural log 3. And then the thing that we remember is that when we have this log form like this and we have this coefficient out front, we can put it up in the exponent. So we've got 2 plus 4/15. So I'll turn 2 into 30/15, and that'll give us 34/15. And then we remember that when we have a log minus a log, we can turn it into a log of a quotient. 3 squared is 9. So what we have here then is 34/15 plus the natural log of 5/9.